I am Melissa Olivia, and I will be talking about how physics is behind cooking. There are three appliances that we mainly use for cooking. There's the stove, the oven, and the microwave. So let's get started. Induction, convection, and radiation are the three elements that are involved in thermodynamics in cooking. Thermodynamics is a branch of physics. It involves heat, temperature, and are related to energy and work. There is an electric stove and there is also a gas stove. There's two types of electric stove. This one uses heating coils and this one has a glass ceramic top. This stove is not really good for cooking because it has a low heat conductivity, meaning that that you're cooking is going to take a while for it to have the desired heat that you want it to have. Inside the metal heating coils, it contains three things. In the very inside it has a resistance wire. This wire purpose is to resist oxidation at high temperatures. Oxidation is when electrons are lost, causing rusting in materials due to high heat. This wire resists oxidation because it has a high electrical resistivity, meaning that it doesn't really allow the movement of electric charge. This is good to prevent oxidation. Resistivity is represented by rho. The SI unit for rho is ohm times meters. Ohm's law deals with current through a conductor. Resistivity is a part of resistance. The formula for resistance equals to voltage over current. When the resistance is constant during that amount of range of voltage, Ohm's law can be used to predict the property of the material. Ohm's law is current equals to voltage over resistance. But if the resistance is not constant, then you have to include rho. The equation would be instead resistance equals rho times length over area. So going back to the picture, around the wire there is an insulator. It keeps in the heat. Around that there is a steel alloy sheet, which has a high heat conductivity. So, how does the electric stove work? Electric stoves are powered by electrical connections. The electrical connections produces power for the heating element. Between the power source and the surface heating element, electricity begins to flow between, to cause the burners to start producing heat. Unlike the electric stoves that are fueled by electrical connections, the gas stove are fueled by external gas lines. The gas lines feeds into the stove by going through a series of pipes. The gas starts to travel whenever the stove is being turned on. When the gas are going through the pipes, it mixes with air. Mixing the gas with air produces the blue color. When the gas goes past the half point of the pipes, it goes through a smaller pipe. This small pipe leads to the pilot light. The pilot light is the small flame that is always lit. The gas in the small pipe goes back down to the main gas pipe. The flame starts to travel through the burner. When you are controlling how much flame you want to have, you are controlling how much gas is traveling through the main pipe. Let's talk about the oven now. More and more people are starting to use the convection oven more than the regular oven. The convection oven has a fan. Its purpose is to keep the warm air moving around in the oven. Having the air circulating cooks the food faster than having the air just being still. The convection oven is powered by electricity to heat the air in the oven. The regular oven is different. There is usually only the heat source on the top and on the bottom of the oven. The oven is also powered by electricity to heat up the heat source. The air in the regular oven is still. Because there's only certain places where the heat sources are located, certain areas in the oven wouldn't be as hot as other areas in the oven. Let's now talk about the microwave. The microwave is related to radiation. Inside the microwave oven there is a device called magnetron. This magnetron produces electromagnetic waves that heats up our food. Inside the magnetron's vacuum tube, there is cathode and coaxial anode. When a direct current that has a very high potential differences goes through the cathode, it causes filament to heat up. When this filament heats up, electrons leave since they are negative charges and they usually float around forces that gives them momentum. Cathode has a negative charge, so therefore the cathode and the electrons will repel from each other. The electrons will now move towards anode, which has a positive charge. The electron travels to the anode by going around the cathode, because it cannot just pass it since it has an electric and magnetic field. So basically what I have just said, the vacuum tube allows the electromagnetic waves to be created. With all these processes being done, the magnetron can produce electric waves that has high power and frequency. Thank you for watching, and I hope that you have learned how physics is behind cooking.